This compute layer consists of clusters of compute nodes in an MPP architecture or a massively parallel processing architecture, also known as virtual warehouses. Each virtual warehouse is a set of compute resources. Depending on its size, that decides how many compute nodes are going to be there, what kind of resources it will have. Each of these compute clusters is an independent resource. It can function independently and execute a workload in a dedicated fashion. Recently, Snowflake also launched container options, which is a pool of compute. You can have CPUs and GPUs in that to run custom workloads. For example, hosting your own LLM, bringing a custom application in a language other than Python, SQL, Java, Scala. Next layer in the architecture is known as Cortex AI layer. This layer provides generative AI services through a set of Gen AI models such as those provided by NVIDIA, Meta, Mistral, or Snowflake itself, either for general purpose work or task specific functions. These models can also be fine-tuned for better performance on certain specific activities. Then the Cortex AI layer has a set of APIs which allow talking to unstructured data through searches or structured data for querying in natural language, or a combination of both through the chat API. And then there is a low code, no code way of building these models and using these models in Studio and providing AI observability within this layer. Next up, we have services layer. This services layer is like the brain of the whole platform, which coordinates and manages all the activities and executes functions via the compute layer or Cortex AI layer. It performs functions such as authentication of users, managing the underlying infrastructure of compute and storage, performing metadata management of all the data stored or the platform itself, parsing the queries and optimizing the queries to run in the most efficient manner, and providing access control through RBAC and other policy-based controls. The services layer does a number of activities for management so that the users don't have to worry about doing those activities. Rather, they can focus on the data. The final layer in the architecture is known as SnowGrid. SnowGrid essentially connects Snowflake instances across the public cloud regions in the globe. So we can have a Snowflake instance running on AWS, Azure, or GCP in any part of the world. And SnowGrid is that connectivity layer which creates this network of the AI data cloud. This layer helps us to share the data across different public cloud regions, provide replication for business continuity functions, or manage all the Snowflake instances as a single organization for a company. Summarize the architecture and what we discussed so far. You can also access the Snowflake documentation page, which shows and talks about these capabilities. Essentially, we learned about different layers of Snowflake architecture, starting with the storage layer, which provides optimized data store, either in Snowflake native micropartitions or in the Iceberg open table format way, where data is optimized through compression, columnar organization, secured through encryption, and then a number of metadata statistics are collected for better performance for the queries. Then we talked about the compute layer, which performs the queries or executes various workloads through the virtual warehouses of different sizes or compute pools of containers having CPUs and GPUs. We then talked about cloud services layer, the brain behind the system, which does all the underlying management and coordination such as authentication, access controls, metadata management, query parsing, and so on. We also talked about Cortex AI and SnowGrid layer. Cortex AI providing generative AI services through LLMs and other models, and then SnowGrid providing connectivity across various public cloud regions across the globe. Let's now look at how Snowflake is deployed. The Snowflake is deployed purely as a service, actually as a software as a service running in public cloud regions. It's truly a self-managed service. That means there is no hardware to install or configure, neither a virtual machine or an instance to configure, manage. There is no software to be installed, configured, or managed. All the ongoing maintenance, management, or upgrade activities are handled by Snowflake. All the upgrades are transparent, non-disruptive, and user does not have to do anything about that. That's how Snowflake is deployed in the public cloud regions.